All right, today we're gonna define the prime factorization. This is this is the last lesson before we move on to the visibility. Now let's just get on to this. Samantha is preparing a large bag of cookies for a bake sale. She decides to make 100 cookies in total to organize. Okay, total. To organize her baking process, she wants to know how to evenly distribute the cookies into boxes. She plans to fill each box with the same number of cookies to help her understand how to organize the cookies. She decides to figure out the prime factorization of 120. What is the prime factorization of 120? And how can it help her find determine different ways she can put the cookies into boxes? I finally got a word problem for you. It is over. The prime factorization is basically taking the big number and splitting up into small factors. Taking the factors, splitting up into smaller fractions, so all the numbers that you had to multiply is prime. 120, it can be split up into two groups. The prime factorization means we're going to factor these out. Since the numbers even, I always like starting at 2. 2 times one number is 120. Correct, 60. We don't have to put multiplication signs since it's prime factorization. Since 20 breaks up, since 20 breaks up into 2 and 60, we got to since 2 is composite, we got to circle the number. I mean, not composite, prime, we got to circle the number. Next, we're gonna take 60 and break it up into smaller groups. Since 60 is even, it can be broken up into 2 again. 60 can be broken up into 2 and 30. 30 can be broken up into 15 and 2. So this can be broken up into 2. But what about it? This can still be broken up into 3. So we're gonna keep breaking these up until we have all the numbers that we is prime. 5 and 3 are prime. So we're gonna circle those 2. So we'll see how we broke this up into smaller groups. You broke up this into a smaller group. You broke up this into a smaller group. And you broke up this into a smaller group. That's because we break up the big number, you split it into small numbers, and the small numbers break up into smaller, smaller, smaller until you can't make them smaller no more. So you have to include the whole numbers as well. So basically, what I'm saying is that since we found the prime numbers, a prime factorization is this. Since there are two twos, that this is equal the two, all the prime numbers, all circle numbers multiply together. So 2 times 2 times 5, funky looking 5, times 3. And if we multiply all these, we will get back to 120. So you multiply all these, we get all the way back to 120. Let's multiply. Remember, we have order in multiplication, so it doesn't matter how you order. So now we're going to have 2 times 2 times 2, which is equal, or 4 times 2. 4 times 2. We're going to multiply that by 5 times 3. And it's a little complicated. I'll just multiply this first because order doesn't matter in multiplication. 10 times 3 times 4. Then we got 40 times 3. And 100% 40 times 3 is equal to 120. And you want to check now? Well, 40 times 3 is 120. So now our answer is 120. And since this is one way she can break it up, if you're a little smarter, you can say that 2 to the power of 3 times 15 is equal back to 120. Want to prove how? 2 to the power of 2 in the power of 3. 2 in the power of 3 times 15, 120. So If you lose your calculator, I don't know if you can see the calculator on my screen, but 2 times 5 in the sometimes 2 to the power 3 is equal to 8. 8 times 15 is 120. That's why our calculations are correct here. All right, good. Now that's what the prime. Oh my gosh, I'm so like entertained with this lesson, I just forget the words. Let's find the prime factorization of 60. Oh, draw 60 like a 60 and 45. 60 is equal to two numbers. What two numbers that multiply will equal to 60? In this case, it'll be 2 times 30. 30 is equal to 5 times 7. One way to express this, but if you want to get to long prime factorization, you can divide by 10, 3, whatever. So I'll divide by 10. 10 and 3 equals 30. Then this is equal to 5 and 2. Let's circle all the prime numbers indicating that if you multiply all these prime numbers here, we get total. So now, the prime factorization of 45, I noticed divisible by 3 already. Because I'm divisible by 2 because it's not even. So I know it's 315. Think about it. These two multiply. Here and here multiply. See, it's here multiply. You get 60. When you multiply these numbers, it gets 45. Now circle this because it's a prime number. This is 1. It's 2. So here is 2 in the power of 2 times 15 will equal exactly that number. We didn't talk about powers yet, but we'll talk about that soon. And something to equal 45, it's 3 3 squared, 3 power 2 because there's two threes times 5. Or instead we're going to say multiply all of the bubble numbers. That just equals to 9 times 5, which is all the way back to 45. Alright, since we understand some pronunciation, I want you to try the problem over here. It's a word problem, so I want you to try to solve it. Okay? You could pause the video if you needed to. I'll give you the entire thing it's working with.